Alright, in this video we're going to be talking about multiplying rational expressions. So when we multiply rational expressions, remember, rational expressions are algebraic expressions that are fractions. Basically, it's a fraction that has a polynomial in the numerator and denominator. So when we multiply a rational expression, we basically do the same thing that we do when we multiply fractions. Right? Remember, if I have two fractions multiplied together, a over b times c over d, I just multiply straight across. I multiply a times c, b times d, I get AC over BD, right? That's how you multiply fractions. You just multiply the numerators, you multiply the denominators, just go straight across, right? Now, remember though, if we can factor our fractions or our numbers in our fractions, if we do that ahead of time before we multiply and we cancel out the common factors at first, it makes it easier to simplify our answers rather than multiplying it first and then trying to factor it and cancel stuff out. Right, so let me show you what I mean by that. Right, so we have 6 over 7 times 5 over 8. Right, so if I'm going to multiply those two fractions, if I just multiply straight across, right, 6 times 5 equals 30, 7 times 8 equals 56, but now I have to simplify 30 over 56. Right, would it have been easier to simplify things when my numbers were just 6, 7, 5, and 8 as opposed to simplifying numbers of 30 and 56? It's going to be easier when those numbers are smaller. Right? And think about it in terms of rational expressions. If I'm multiplying these two down here in example B, imagine multiplying the x squared plus 2x minus 3 times the 3x plus 12, and then multiplying the x squared plus 8x plus 16 times the x minus 1, and doing all the work to multiply that out, and then trying to figure out how to factor that so that you can simplify it. That's a lot of work, and I do not want to do that, and I do not want you to do that. If you're a student in my class and you start doing all that work, then I have to do all that work to make sure that you did it correctly. I don't want to do all that, right? So what we want to do then, rather than just multiplying straight across, whether it's a fraction or rational expressions like we have here, we want to try to factor it first and cancel things out so that it's a little bit easier for us to simplify our answer, right? So 6 over 7, well, 6 is equal to 3 times 2. So I can write that as 3 times 2 over 7 times 5 I can't factor. Right, and the 7 down here, I can't factor 7 either. 7 is just 7 times 1. There's no other numbers that multiply to equal 7. Same with 5, it's just 5 times 1. 8, though, is 4 times 2. And since I have a factor of 2 in my denominator and a factor of 2 in my numerator, I can cancel those out. Right, remember, I can do that in fractions because I'm just going to multiply all these together anyway, straight across the top and straight across the bottom. So a factor in either one of these denominators can cancel out a factor in either one of those two numerators, because once I put them together, they're all going to be in the same fraction anyway. All right, so if I do this, now when I multiply 3 times 5, I get 15. And when I multiply 7 times 4, I get 28. And my answer is already simplified because I already canceled out the common factor that I had, right, that 2 that I had in my numerator and denominator. All right, so it's a way to make simplifying fractions and multiplying fractions a little bit easier is if you factor first and cancel things out before you actually multiply. Right? When you're doing it with numbers like this, it's not that big of a deal. Like what we had up here before when I just multiplied straight across, I had 30 over 56. I can divide both of those by 2 and get 15 over 28. It's not that much more work to do that. But when you start doing rational expressions like this, it's going to be a lot more work to do it the original way as opposed to doing it this way. Right? So we always want to factor first and cancel when we are multiplying rational expressions. We never actually multiply these things together when we're multiplying rational expressions. It just creates more of a mess than we actually need or that we want to deal with. All right, so I have x squared plus 2x minus 3 over x squared plus 8x plus 16 times 3x plus 12 over x minus 1. So what I want to do here before I multiply anything is just factor everything that I can possibly factor. All right, so for my first fraction, the x squared plus 2x minus 3, all right, that's a trinomial that I have up top. So, and it's a 1x squared, which tells me I can split up that x squared into x times x. And then to get my other two numbers here, I look for two numbers that multiply to -3 and add up to 2. Right, so multiply to -3, add up to 2, that's going to be a +3 and a -1. Right, those two numbers multiply to equal -3, those two numbers add up to +2. And again, if you haven't looked at my videos on how to factor, I did a number of them with a bunch of different factoring methods. I would advise you to check those out. Again, factoring is a really important skill to have, so make sure you understand how I'm getting all these numbers here, where all this stuff is coming from. All right, so that's my factors of x squared plus 2x minus 3. The denominator of that fraction, the x squared plus 8x plus 16, well, is once again a trinomial with a 1x squared, which means I can put the x and the x here, and then I look for two numbers that multiply to 16 and add up to 8. All right, so those two numbers are going to be 4 and 4. All right, 4 times 4 is 16, 4 plus 4 is 8. So x squared plus 8x plus 16 factors into x plus 4 times x plus 4. All right, and if you're pretty decent at factoring trinomials like this, it's not that hard to do that. If you're not that good at it, practice as many as you can, because like I said, factoring comes up with all kinds of different applications and all kinds of different problems that you do. You're going to have to factor a lot, right? So you have to understand how to do it. All right, the next fraction, I have a 3x plus 12 over x minus 1. Right, so that 3x plus 12, can I factor a 3x plus 12? You might look at it and say, well, no, because it's just an x. It's not like a trinomial like these are over here, so there's nothing I can do with it. When you have a binomial like this, right, two terms, there's a couple things that could happen. It could be a sum or difference of cubes or a difference of squares. Well, it's not that because it's not an x squared or an x cubed, so it's not going to be one of those things. The only other option you have to factor when you have a binomial is a common factor. And in this case, the 3x plus 12, they do have a common factor of 3. Right, so I can pull out that common factor of 3, which will leave me with an x plus 4. Right, remember, factoring out the common factor is like doing the distributive property backwards. If I distribute that 3 back into the parentheses, I would get 3x plus 12. Right, my denominator here, the x minus 1, well, that one I'm not going to be able to factor at all. Right, again, it's not a difference of squares because we don't have an x squared here. It's not an x cubed, so it's not going to be a sum or difference of cubes. And the x and the minus 1 don't have any common factors that I could pull out, so that's just going to be an x minus 1. All right, so I have factored everything that I can, just like in this one up here with the fractions, with the numbers in it. I factored every number that I could factor. And now what I look for is, well, what can I cancel out? What common factors do I have in my numerators and denominators? Well, I have an x minus 1 in this numerator, and I have an x minus 1 in that denominator, so those are going to cancel out. I have the x plus 4 up here. That's going to cancel out one of these x plus 4s down here. Right? Remember, when you're canceling out the factors in the numerator and denominator, it has to be like a one-to-one canceling. This one factor cancels out just one factor down here. If I have another one that's the same, this one up here will not cancel out both of those. Right? It can only, one factor cancels out one factor. One factor can't cancel out two factors. All right, so it's an important little thing to keep in mind. All right, so what do I have left here after I do all that canceling? I have a 3 and an x plus 3 are my two factors left in my numerator. And in my denominator, I just have a factor of x plus 4. All right, so notice, in my denominator there, that x plus 4, I don't have to put that x plus 4 in parentheses because it's the only factor that's left. And since it's the only one there, I don't need parentheses around it. In the numerator, though, I have two factors, a 3 and an x plus 3. So that x plus 3 does still have to be in parentheses. And usually we put, if we have just a number as a factor or just like a single variable like an x, usually we put that in front of the parentheses as opposed to behind it. Right? You could write this as x plus 3 and then the 3 at the end of the parentheses, but generally we put that number in front, 3 times x plus 3 like we have here. Right? And usually when we are multiplying rational expressions like we did here, if we have more than one factor left, we generally do not multiply those together. The reason for that being, just in case we miss something, like maybe there were so many factors that we had here that I didn't notice that I had an x plus 3 here and another x plus 3 down there, but now when I put them together, I see, oh, I have an x plus 3, I can simplify this a little bit further. So generally we leave it in the factored form when we give our answers to these types of problems. And that goes not just for multiplying rational expressions, but when we do dividing and adding and subtracting rational expressions as well. Generally, we leave them in the factored form. It's usually more convenient for us to work with them that way. When we have to do other stuff beyond this, we want to have it in that factored form. Right? So you don't actually have to distribute that 3 and multiply it by the x plus 3. You would leave it just like I have it up here. All right, so that's multiplying rational expressions. All right, remember, we don't actually multiply. Right? I don't actually take this and multiply it by this and take this one down here and multiply it by that. That's a whole lot of work, and it just creates a huge mess of stuff that you end up with. What we want to do in order to get our most simplified answer is to factor everything first. Anything that can be factored, we factor using whatever factoring methods we need to use, and then just cancel out our common factors, and then we get our answer. All right? So that's multiplying rational expressions.